Then welcome to this introduction to Git and GitHub. My name is Karsten Beismann. I'm a data scientist and I'm working for the DHL group. I'm mostly designing and maintaining machine learning pipelines, mostly for finance use cases. And I happen to work a lot with Git and with GitHub. So why am I doing this? Like I said, I work with Git every day, basically. It's an incredibly powerful tool. And nowadays, pretty much a necessity when you want to do collaborative work, if you want to work on other code bases and so on. So no matter what you do, as soon as you're coding, you probably have to use proper version control to collaborate and to track your code base. And that is nowadays mostly Git, even though there are alternatives. It's the most popular one. And it's well worth your time learning, actually. So at first, Git seems like a terribly complicated tool, but believe me, given time and especially given repetition, you'll be much more comfortable using it. I think it's really important to mention that it really takes time to master Git. Don't be impatient, but it is practically the lingua franca among programs, I would say. Not necessarily the language is the lingua franca, but it's just a tool that pretty much everyone is using. So learning Git properly is a very, very good investment. What are we doing today? So firstly, this is obviously a very shallow introduction to Git and GitHub. So we will talk about what Git is and why you should use it. And we'll go through a few essential Git commands that are basically your bread and butter commands when working with Git. We'll also talk about a few very basic GitHub features. And we'll try to do one simple contribution cycle. So basically, I wrote down a few basic commands, and we'll create a small repository, not live, but I basically have the code for that. And you in your own time can basically copy those commands and you can do the same thing and hopefully learn how this basically works. And at the end, I'll give a short outlook on advanced Git topics. So basically topics where I think that it's a good idea to dive a bit deeper into them and to learn what's behind them. So that's the content for today. My assumptions regarding what you're bringing to this presentation is that you're mostly new to Git and GitHub, because if you're not, then this will be a waste of time for you. This is really, really basic, but I hope that you have some basic knowledge of how to run shell commands. That's really important. Here in this case, and I have to add this, I'm basically using a Linux console. I think it doesn't make much of a difference because you can use Git on in PowerShell as well. But I'll just assume it's Linux because that's usually the tool that people use, either on a Linux PC or on WSL, which is Linux for Windows. Okay, so why Git? And I think this is an amazing example because that's usually how your project looks like if you're not using Git, and you might think that this is very, very familiar. You have a number of files, probably multiple files with code. Let's assume this is just a text file here in this case, could be a Py file, whatever. And you have to version it somehow. You have to have firstly backups, and secondly, you want to track your changes. And maybe multiple people are actually working on it. So this is often a very, very common scenario. You have multiple files, and then you have version 1, version 2, version 2.1, and so on, different ways of naming them. In the worst case, you have something like final text or something like that. But you can imagine this is already kind of becoming an issue. Firstly, you don't have a history, right? You cannot track your changes over time. Maybe implicitly by having different versions, but actually going through those files and understanding how your code base evolved is very, very difficult. Then secondly, the collaboration is really difficult because maybe if it's on a cloud, multiple people are working on the same file, that might be an issue, or even worse, everyone has a copy of every file locally and is working locally, and then you somehow have to manage to merge those changes into a single file. Also very, very laborious and difficult. You don't have branching and merging, which is something we'll talk about later, which means there are no separate lines of development. You just have this one, like either you have really separate projects on each PC basically, or you have just one. You don't have proper backups potentially. And of course, tracking changes is also very, very difficult because you have those files in different versions, but you don't have a systematic way of actually tracking what changes between those versions. And Git is basically the most common answer to all of those problems. And because I think it makes sense to talk briefly about the history of Git, just to know where it's coming from, I just added a few points to that. This is firstly, until 2005, version control was often very, very simple if it was used at all in major projects. And that was a major issue for Linux in this world, the distribution Linux, or for the maintainer Linus Torvalds, because Linux, as you might know, is a huge open source project with a lot of people all over the world contributing to it, and it became incredibly difficult to manage it properly. So Linus Torvalds saw the creator of Linux saw that as a problem, and to solve that, around 2005, he developed this tool called Git, to basically handle the Linux code base, and that's where it comes from. So originally, Git was developed as a tool to facilitate collaboration and to manage the Linux code base. And nowadays, it's basically used in pretty much every major project, with a few exceptions, of course. So what is Git exactly? It's firstly an efficient version control system, which means it tracks changes. Whenever you change something in your code base, Git will track it and keep it forever, basically. Changes are never lost. You can revert stages, because if you change something and you don't like your change, you can at every point jump back in history, basically. You can travel back in time and go to a different state of your project, because you realize, oh damn, I incorporated a bug, for example, I added a bug, and I would like to revert that. They can always do that, and it maintains a very, very detailed history, because every single change is kept and archived. Then, of course, equally important, it enables collaborative development, because every person has firstly their own version of the code base on their local machine. And on top of that, for every change, you can create your own copy of the whole code base. So it's a very, very systematic way of working on a code base, because every person can basically create their own version. And then there's a systematic way of bringing all those versions together. It's the second part. And lastly, I kind of mentioned that before already, it is distributed and decentralized, which means every single developer has a complete copy of the project, which means not just all files, all the code as it is, but the whole history. Every single change is on every single developer's local machine. So those are the main purposes. I think you can nicely summarize them as tracking, collaboration, and backup. Those are the main purposes. Before we continue, and I know it's kind of difficult to talk about those terms without really seeing what they do, I would just like to mention a few basic terms in Git that will be fairly relevant. I will just briefly go over them, just so you kind of heard them once, and then maybe in the following slides they will make much more sense. So a very important term is the repository, for example, which is basically the entire code base and its history, everything, just basically everything. That's called a repository in Git. It's one kind of on your hard drive, one folder, but that folder is basically governed by Git, and that makes it a repository. Then you have commits. When we talk about a commit, we mean a single change in history. So that's one code change that is committed to the repository as a commit. Usually there's a comment attached to that. I changed line 5, and that's basically your commit. Then we have branches. Those are separate lines of development. It's a bit difficult to explain in theory or here, and we'll talk about that later. We have a merge, equally difficult. It's when we have multiple branches. Multiple developers have multiple branches in Git, for example. Everyone is developing their own features, their own version of the code base. At some point, we have to combine them, and combining them is called a merge in Git. Cloning is simply just creating a copy of the repository. That's nothing but downloading the code. That's called cloning. Pulling is when I want to have the changes from a remote repository locally. You can just pull it. Pushing is the opposite. You're sending changes from local to remote. And staging is basically marking changes. So those are basic terms you'll stumble upon when you work with Git. but I think just using them will actually make much more sense, or will make it more clear what they actually mean. The Git history, and this is just the first. This picture will reappear in the presentation multiple times. This is just a nice way of visualizing how a Git history actually looks like. Basically, you have branches here, the names of the branches, and let me maybe briefly look for a pointer. Is it possible?
We can see your mouse, so.
Oh, you can see the mouse. Okay, perfect.
Yeah.
Yeah. So basically, we have different branches in this case. Master or main is one branch. New feature would be another branch. Those are parallel lines of development. Then those blue dots are basically commits in history. So at every single dot, you have all the files. Like all the files always exist for every single commit. But they develop in time. As you can see, we move into that direction. So we have one state of the repository, this commit. Then we have another state here on master. Then we create a branch. So one developer decides, okay, I want to develop my own feature. I call this branch new feature. And I develop commits there. This basically happens in parallel to master here or main. Then there's another commit. And in the end, we basically merge it back into main. And we have, again, one code base. That's just a brief description of how the Git history actually looks like. Before we continue with Git, I'll say a few words on GitHub because the contribution cycle that I prepared later on uses both. So I think even though there's a bit of a context switch, we'll just briefly talk about GitHub, so you know what that actually means and what that is about, and then we'll switch back to actually implementing our first repository. So what is GitHub? GitHub is a web-based platform for Git repositories. Well, it's self-explanatory, I guess. But basically, the idea is I earlier mentioned that every developer has one version of the repository on their machine. With GitHub, there's one main repository on a website, basically on the web-based on the platform GitHub. And that is basically where you would pull the repository. If you would want your copy of a code base, you would basically pull it from GitHub, and GitHub on top of that would facilitate cooperating with other people, collaborating rather, creating so-called pull requests, which means you want to change something in the code base, and tracking issues and so on. It's just a platform with a number of different features that are very, very difficult to summarize here because they're really, really a lot. But long story short, it's basically this one repository on the web that is kind of the main repository. And whenever you change something and you want to contribute this to this main repository, you have to push your changes to that Git repository. It was founded in 2008. It was bought by Microsoft in 2018. And that's just straight out of Wikipedia, just to kind of show you how important GitHub is nowadays. There are right now over 100 million developers on. Can you?
We cannot see the presentation.
Yeah, it's just closed. Just as additional information, there's an update right now in the background that seems to do things. I cannot interrupt it, so don't be surprised if stuff like that happens. I'm really sorry for that.
No problem. Hopefully we don't lose you.
But there are some questions in the chat.
Yeah, shall I read some of the questions?
Please.
While we're waiting for it to, okay, so there's a question, is a commit depending on a logic that defines who has to sign it off, or can anyone change the code without others checking that?
Well, a commit is always a personal thing, right? On your branch, basically, in your repository, you can always create commits as you want. A commit basically just means there's a change and you're kind of signing it with your name and your email address or whatever it is, right? This is your change, and that we can do that always. But before contributing to a code base, you would basically push those changes, those commits in a branch. A branch has usually multiple commits, and then another person would approve those commits and they would go into the main repository. I'm not sure if that's an answer to that. but commits you can always
Yep.
create.
Yep, thank you. There's another question. How can we handle hot fixes?
So usually, usually the idea would be you have an up-to-date version of the repository on your local machine. You would create a branch called hotfix1, for example. Then you would create a commit on that branch that fixes that hotfix, and then you would push it back to GitHub. And on GitHub, someone would review this change, would say, okay, this is fine, this looks fine, seems to solve the problem, and then merge it back into main or into the main repository. That's usually how it would work. One moment, I think I'm back, hopefully.
Yeah, we can see
Perfect.
the screen.
Very good.
Is it okay?
Okay, sorry for that.
If I comment on this answer, because I asked the question.
Sure,
Yeah,
go ahead.
Okay. So what happens in here specifically, if you have a branch that you are working on, and all of a sudden you figure out problem with the production, and you need to apply hotfix, how this hotfix to be applied on both production and at the same time on your branch that you already have it different from the production.
Okay. So the idea would be, so firstly, the hotfix is separate from what you are working on. Therefore, the hotfix would happen on a different branch. So you have main,
yes.
You have your branch. You would create a new branch for
Yeah.
that hotfix. Let's call it hotfix branch. Then you would fix it on that branch, merge it back into main, and then you would merge main back into your current branch.
Which is gonna take off almost all the changes you did on your branch, right?
No, the changes on your branch will still stay, right? I mean, will still be there, but you would merge basically the hotfix branch into, the new updated main branch where the hotfix was already applied back into your branch. You would update your branch with main. That being said, there are multiple ways of doing that, but that's basically the short answer.
I mean, if your fix as well is in a commit, you can do a cherry pick to that commit, and then
that's also an option. Yeah.
Thank you.
Okay.
Okay, we'll pause the questions now and let you continue.
Yes. Yeah, just to give just to give you a feeling of how important GitHub is right now. There are around 100 million developers on GitHub. There are more than 372 million repositories. It's pretty crazy, and 28 million of those are publicly available, which makes it the world's largest source code host as of 2023. That's quite substantial, actually. So usually nowadays, most major projects have some kind of presence or some repository on GitHub. Okay. So the first steps now, and I assume that this is just stuff we cannot go over here right now because an hour is very little time, obviously. You have installed Git already. There are some links here as well that you can use later on if you need help with that. I assume you created a GitHub account as well. So one of the first steps would be that you set up your Git configuration. Again, there's a link that might help you do that. And you would create your first repository. Basically, you're creating a repository here. With those steps, you would find a repository name. You can decide, do you want to have it public or private? Public means everyone can see it. Private means only you can see it, or the people you choose to collaborate with. You have additional options here, like adding a README file, for example, and some other options. But I think this is the most important basic step. And then you would click on create. You would create your repository. I assume you haven't set up SSH. It's also another different topic. So you would, for now, rely on HTTPS. You would basically copy this address here right now that you can see. The HTTPS version looks a bit different. And then locally, if everything is set up correctly, you would clone the repository. And in this case, I'm creating a directory called gitdir. It's just my convention. You can pick another one. You go into this directory and you clone that repository. Then one very, very basic command. Now you clone basically the repository. You have a local version of the whole code base and all the history on your desktop. One very basic command that I want to mention as early as possible is git status and later on the git log. Git status is something you should use very, very often because it gives you a brief description of how your repository right now looks like. Do you have any changes that are not committed? Which branch are you on? Is your branch up to date? Stuff like that. So when you are, just a general message, when you have issues, one of the first steps you should use when you're really confused right now, use git status and just check what what git status basically tells you where you are right now, because knowing where you are helps you solve a lot of problems. Just as a brief summary here, there's one. We see here one branch main. That's basically the name of the branch, and your branch is up to date with origin main. Just as a brief description, what that means. What happens in the background, without really going into details, is that basically Git works a bit like this. So basically, you have a main, you have the main branch on the remote repository on GitHub. This is this part here. When you pull it, when you want, or rather fetch it to have it on your local repository, you use git fetch, and then those changes are forwarded to a tracking branch that you have locally, which is called origin main. So when you hear origin, which you will see a lot actually, is why I'm mentioning it here, in case you're confused, origin means this is your local copy of the remote branch. In this case of main, the branch is called main. This, you never, that's why it's red, you never modify this one. But you have your, for example, main branch local, which is just called main, which is the version you would actually change. So to go through the cycle, as you do git fetch, main is pulled to this origin main branch. So all the changes on remote are pulled to this tracking branch. And then with a git merge, which you usually don't use, those changes are forwarded to main or merged into main. There's one command that combines both, which is git pull, which is what you usually probably know already and what you usually use. Basically, that's the cycle in one single command, fetching and merging into main. And then pushing is basically the opposite. Your local changes, your changes in main are pushed to the origin main or merged into origin main, and this is pushed then to remote main. It's just a very brief explanation of why those different terms exist, because they can sometimes be very, very confusing. Then we'll briefly talk about another concept that we just saw. I think that was actually mentioned here, or it's rather not mentioned here actually, which means that there are no stage changes. But what does staging mean? Which is also something that appears a lot. And I think it makes sense to briefly explain that. And the best reference that I have, the best comparison that I have, is that staging in Git means like marking a text. So when you have a doc file, for example, in front of you, and you want to change something, you want something in italics, for example, then you are marking the parts in the text, the words you want to have in italic, and then you're using the command italic, right? And staging is the same in Git. Basically, staging means you are marking changes that you want to act on. That's why I'm mentioning it here, because there are sometimes changes that are unstaged and staged changes, and you can act on them separately. So the best way of thinking about that is that it's like marking text, basically. That's basically staging in Git. Usually you have to stage changes before you commit them. So you stage whatever you want to commit, which could be a subset of the changes that you're having right now, and you can commit them. Or you have unstaged changes that you want to throw away, then you're stashing them, for example. It's called stashing. It's when you remove changes. So now knowing that, you've seen git status, you know what staging means. We'll create our first commit actually, which means we are going into the repository which is created, or which is cloned rather, first project. For the first command is touch file 0, which just means we're creating this file. And we forward one line of code into this file. This line cat file 0.txt just checks it so you can see how it actually looks like. Then we're staging this file. In this case, the git command is git add file 0.txt. Staging means we are marking the whole file and all the changes in those files for the next step of whatever we want to do. And what we want to do is git commit. So we're committing with an M, we're writing a message, first commit, which means all those changes, this file now is added to the current, basically to the current Git history as a commit, as a change, and then we push those changes. This would be the first step. This would be your first commit on main. on the main branch basically. And that's where we are right now. This is the first commit. We basically created in this this picture that we saw earlier. We created the first commit. And then a second command that I really want you to remember actually. Git status is the first one. Always check git status if you have a problem. Secondly, if you have a problem, try to look at git log, ideally one line graph. Those are two flags that I really recommend. It basically gives you a printout of the current Git history. And here you're seeing the example for the repository I created for this purpose. As you see, this is usually a graph. You can't see it here right now because we only have one commit, but we have one hash, which is this one. A hash is basically a unique identifier for each commit. And then a short description, let's ignore this. And then the title of the commit we just saw, first commit. We know our repository has one change. This change is called first commit and has this hash. Again, use status and history, the history command or the log command liberally, really use it a lot. Whenever you have an issue, check out those two things first to understand what is happening in your repository right now. So we create the first commit, and now we want to create a branch. Oh my God, sorry. Can you still see my screen?
Yes, we can.
Okay, thank you. So now we want to create a branch. And now we're kind of here. So we are on this main branch in this case, but we want to create a new feature, right? Which is the second branch we can see here right now. We're kind of here with one commit rather, not two, but one. So to create a branch, which is your own copy of the whole code base again. So in your repository, which is already a copy of the whole code base, you now create a branch, which is again your own copy of the whole code base that you can edit without changing the main code base. And we do that by using those commands. We do git checkout main, which is actually redundant, sorry, because we are already on main. Checkout just means that we are switching to main. We do git branch feature one, which means we create a new branch called feature one, a new version of your of the code base. And we do git checkout feature one, which means from main we switch to the branch feature one, which will right now be of course identical because we didn't add a change, but we are on a new branch. Again, if you do that at home, try to use git status and git log just to check out the status to understand kind of what's going on and to get a bit of feedback from Git. And then we do basically this, or rather this. Basically, now we're creating our own changes in our own version of the code base without touching main, which means we do touch file one, we add a new file, we add one line of code to this file, feature one, we stage that file as before, we commit that file with a comment called add feature one because we want to explain what we are doing, right? And we push that. So now we added in our own branch a feature, one line of code basically, and we're here. And now the second part is, of course, how do we get this new feature that we just created, this one line, back into main? And that is merging. So what we do now is we go back to main. This is our main branch. Git checkout main. And then we use git merge feature one, which means we are merging the changes that we have on feature one into main, assuming there are no conflicts. Right now I'm ignoring conflicts because it's a bit too much for this presentation, but assuming there are no conflicts, and there are not because it's a new file, and that file does not exist on main, this should work out perfectly fine. And when checking git log one line graph again, you'll see that another commit was added in the history. So basically you will see, if you're here, you would see that you have another commit in this history. And now we did this locally, of course, and because we have GitHub, I would just like quickly show you how to do that remotely as well. The same process, but this time we'll basically create another branch. We'll push that branch to GitHub. We'll go to GitHub, and then on GitHub, we'll basically review the changes that we just did and merge them on GitHub back into our main branch and update it. So we, again, create a branch called feature two, in this case, git branch feature two. we'll switch to this branch with git checkout feature 2. We create the third file, which is file2.txt. We add this feature 2 to the file2.txt. We stage the whole thing again, we commit it, and we push it. It's basically the same thing we did before. But the difference now is that we go to GitHub, instead of basically doing it locally, we go to GitHub, and you'll see if you go on pull requests, which is a tab you'll see on your GitHub homepage, on the repository homepage rather, you'll see that GitHub will tell you feature 2 had a recent push less than a minute ago, probably because you're doing it very recently. And there will be this button called compare and pull request. And this is basically what you'll click. And then you're getting a window like that. Here we'll see the base branch, which in this case is called main, because we want to compare those features to our current main branch. And we compare it to feature 2, which is the branch you're working on right now. And then you, for example, especially if you're collaborating with other people, you would add a number of comments, a number of or just a description in general. I want to add feature 2. It's very useful, and please review this pull request, right? You can also add reviewers here if you happen to collaborate with people. You can assign it to yourself. You can add labels, stuff like that. It's just things that are supposed to facilitate collaboration. And of course, you can create the pull request here. This is what you will click next. You're creating the pull request. So now you basically created a pull request, which means you are asking other people potentially to merge those changes into the main branch. And if you click on this tab here, for example, in GitHub, files changed, you'll basically see this diff, very simple. You know already what we did, right? We added a file called file2.txt. This is basically the GitHub view of what we just did. And then we added one line of code called feature 2. And here we have the option of reviewing those changes, basically. You can click on this button because you are fine with this. And then basically you can approve, sorry, you can't see that here, but then you basically click on approve because you approved it. Or someone else is approving it. And then in the PR further down, you'll see this one, which is merge pull request here. And this is basically what you will click next. And then the result will be that this branch right now, the remote version of your branch, your feature branch, feature 2, is merged into main. So the main branch has changed. And now your local repository, of course, is outdated, right? You have to update your local repository. So what you'll do, actually, you first go into your local repository and you do git checkout main. We're switching to main again. And then you'll do the command git log one line graph that I just showed you. And this is the old, because we haven't updated main yet. This is the old status. Remember, this is the first commit. This is the first commit with the respective hash. Then we see the second commit that we created as well and merged into main, add feature 1. And now we will update main by using git pull. Always ignore git checkout main. It's just, I'm just adding this so you know that you have to go to main. Git pull, and which is updating main using the remote branch that we just merged into. And then we do git log again to see how the repository history has changed. I think this is a really nice way of visualizing that, actually, and the result will look like this. In this case, we see there is a merge commit because GitHub is making sure that the branches are tracked as well. And by keeping that information, or to keep that information, they're creating so-called merge commits, but won't talk more about that because it's a bit more complicated than that. But what you can see here is the first commit again, the second commit, and then we're branching here. We created another branch called feature 2, which is documented here, add feature 2, and the changes of this branch were merged into main. This is basically very nicely visualized here. I hope that's kind of intuitive. And that's the current status of main. So now we basically updated the main branch twice, once locally by merging it into it locally, adding feature 1, once by adding feature 2, pushing that, and then merging it on GitHub. Using the visualization before, we are now around here. So we have the main branch, we changed something here, we created a branch, added features, and then merged them basically back into main. And that's pretty much it. That's basically the content of a simple contribution cycle that you can repeat at home if possible. I just added a few. This is basically the main content, so I hope we have enough time for answers, because I'm sure you have quite a lot of questions. But I'll just briefly talk about a few concepts that I would recommend looking up, because they're very, 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 very helpful. And maybe that gives you an initial direction if you want to get deeper into Git and do more than just commit. And that's firstly, committing lines of code instead of files. I think that's a very, very important concept. So you just saw in my previous commands, if you remember, I just stage files, git add files. It's also possible to stage fractions of a file, or just fractions of a change of a diff. And it's very, very useful to have more fine-grained commits with better descriptions, instead of having, as you can imagine, I don't know, 100 changes in different kind of changes that are very difficult to track, and you're just committing everything. That makes it possible to break a commit apart, or commit or to break a diff apart and to commit it separately. So I would really recommend getting into that as well. Then a second very important concept is a reset. So we said that Git makes it possible to jump back to a previous commit. So let's assume here right now in this scenario, we realize, oh, damn it, this commit is feature 2 is not working at all. I would like to go back to this commit, for example, to feature 1. At that point, the code base was still working. I want to jump back. And you would do that by using git reset, either soft or hard. So those are 2 commands I recommend getting into as well. Basically, by using get reset soft and then the respective hash, you will jump back in time. You will remove and delete all the commits between the current commit and the commit that you want to jump to. And you're keeping the changes because it's soft with the soft one, and you're throwing away the changes with hard. So this is really, really useful. In general, if you want to get even further into Git, changing the history, for example, then rebasing is a word you should keep in mind. If you want to do that, then look up rebasing. It's way more advanced, but incredibly useful. Something I want to mention as well for people that are new to Git is usually Git keeps everything, which means it's very, very rare that you'll be able to break something in Git and you won't be able to revert to it. Even if you reset, even if you merge, it doesn't matter. Everything is basically tracked. And if you have the problem that you, for example, lost information, you lost commits because you resetted too far, or you did something similar, you lost something, check out git reflog. Basically, git reflog documents all the changes you did to the repository, even when you change history. So if you have that kind of issue, look it up. This will be incredibly helpful. Usually in Git, you can revert everything. And I mean really everything. Which is basically the next point. Everything can be reversed in Git, even a changed history. Since this is originally for data scientists, right? I know a lot of data scientists are working with Jupyter Notebooks. Jupyter Notebooks have their own problems with Git because they're just more than just source code. So Git works incredibly well with source code. It doesn't work well with HTML files, or in this case, Jupyter Notebook outputs. The diffs just don't look very nice. It's not informative at all. I would recommend checking out, I think it's called NB stripout, because it basically removes additional information in Jupyter Notebook files and makes the diffs look very, very nice. So this is a huge recommendation if you're working with Jupyter Notebooks. And lastly, I want to mention CI/CD pipelines. So if you want to have automatic checks, one example would be a black formatter. If you're working with Python a lot, you want to always check if the code was correctly formatted in black. Then you can use the GitHub Actions functionalities that are way more complicated, but I'm just mentioning it here so you know that this is possible. Basically, there are a number of checks that would run every time you push something to the repository. It would check automatically if there are any flake 8 errors, for example, for Python or other things, and then refuse to merge that into main. So those are really useful concepts. If you want to get deeper into Git, this is what I would recommend. And lastly, of course, the sources, which there are not many. It's basically GitHub, and this very, very informative website, Git book down, is extremely useful. Okay, that's basically it. I would say if you have questions now, then please go ahead.
Yeah, there are some questions, so I'll just read them off from the chat. But Lutz, thanks for also answering some already. Oh, Omar, go ahead.
Yeah, hello, can you hear me?
Yes, we can.
Okay, so for someone who is very new to the concepts of GitHub and coding, actually, I don't have very much experience or knowledge about that. Do you think that data analytics and coding or GitHub, these things are very related, or do we need to, get our hands-on experience on GitHub in order to learn data analytics or data science?
I'm not sure if you'll like my answer. I kind of mentioned it briefly at the beginning already, but I think as soon as you are working with code, I think you should be able to use GitHub and Git, mostly Git. GitHub is just an extension of that, but yes, you should be able to use Git. I know with Jupyter Notebooks, for example, it's not as useful, but as soon as you are actually working on major code bases, as soon as you're working on bigger pipelines, and they're usually in, for example, Python files and so on, Python repositories, you should really, really use Git. I think some basic commands are already enough. For example, what you've seen here today, I think, is already fairly a good basis to at least be able to collaborate. But I think it's a skill that's well worth your time investing in, especially since it's much easier for your colleagues potentially, or the people you collaborate with, to work with you if you are somewhat able to use Git.
And also just to highlight from the fellowship perspective, for your end of fellowship project, you will need to be using Git. So it's important that you also take some time and play around and practice with it. And
it's really a skill that ages very well. I can't emphasize that enough. No matter what you work in, it's really useful.
Sorry, if I may add, actually, maybe it is worth that to read about something called Git flow to understand the flow of the work when you are utilizing Git, and utilize a UI. Like there are plenty of UIs that are useful, that you can apply the concept that you learned from the Git flow into a user interface, and then it will make it easier for you not to remember all the code, all the scripts that to run. I'm not sure. It's just a tip, but I'm not sure if it is useful too.
Yeah, just to quickly add to that, that's true. The thing is that there are lots of different software packages that actually deal with Git. But I agree, it's a very good idea to find a package that actually, or a software that works for you, especially when tracking and visualizing Git repository history. Usually those programs help you to commit and to merge and so on, especially when you have conflicts. Then using Git can be really, really difficult, especially when you just use a command line. I think all those tools help you a lot. There's just so many that it's very difficult to make a good selection here right now, but that's a good advice indeed.
There's another question in the chat. The question is, what about GitHub desktop? Can't we do all that was shown here with it?
That's possible. I don't know GitHub desktop personally, to be honest. It's possible that it will help you to do that. Keep in mind that often certain Git functionalities are not covered in those apps. So sometimes you have to do something that is not covered there, so you'll have to go back to the command line. I think for just basic stuff, they're probably enough. But it's always good to know where it comes from, and the most basic commands are well implemented obviously in as a command line tool. So I think that's usually where you should start, but definitely very helpful. Yeah.
The next question is there a website or documentation that you would recommend for us to familiarize and practice using GitHub or Git?
Well, GitHub is documented on GitHub, I assume. But Git, yes, that's basically what I mentioned here. This is a source I would recommend that I think is very, very useful. Git book down. There are actually multiple. I think you can basically not go wrong. I know that Atlassian, I didn't add that here because I didn't use it for this presentation, but Atlassian, I think it's called, has a very, very in-depth Git documentation. So usually using those sources, you can solve a lot of problems already. Yes.
There's a couple people who would like to know what the best way to have practice would be using Git.
How you practice with it?
Yeah, to get familiar with how to use it.
I think the best idea usually is to work on something you don't care about, and that doesn't mean you don't care about the code base necessarily, but something you can break. So either you are creating a temporary repository like I did, for example, as like first project, and then you're just playing around, creating a bunch of commits, creating a bunch of branches and so on, and you don't really have to worry. I think that's always a very, very good idea. But also actually, if you can just clone one of your favorite code bases, let's say pandas or let's say sklearn, you can just clone that and you can just create branches and play around as well. I think that's usually how you learn doing that. I think that would be my main recommendation, because of course you always learn by using it, by actually working on a project with Git, right? But it can be very, very useful to just play around with it.
We have another question in the chat. Is Git and GitHub posing any risks for proprietary code? Can the code be stolen by hackers or accessed by the Microsoft since they own it?
Interesting question. Well, if you have a public repository on GitHub, then of course it's by definition public, right? Which means that everyone can see it and everyone can access it and everyone can potentially use it. On GitHub, you can by default, and you can see that in one of the earlier slides, it's not really preventing anyone from copying it, but at least legally it's maybe interesting. Choose a license already if you want that. Again, there's a private and public option. If you really don't want people to access your code, then the private option is obviously the one for you. In terms of Microsoft using the code for example, their LLM models, I'm not sure if you can do anything about that, to be honest. I'm not too deep into that topic.
Yeah. Just in general, if you are part of a larger organization, it might also be worthwhile to ask around if your organization hosts their own GitHub or similar software. So for example, within DHL, we do have a DHL hosted GitHub. That is software that we basically buy from Microsoft, right? But is completely separate. So Microsoft cannot access it legally, at least. So there are different products that work very similar to GitHub. Not everything is GitHub. And maybe these things already exist within your organization. And then you are very much safe because it's completely internal to your organization, and nobody outside of your organization has access to it.
Thank you. One more question. Who approves / checks the merge of branches? Is that the project owner?
On GitHub, yes, it depends on who's a collaborator on GitHub. You can basically add different collaborators. Usually, of course, the project owner is someone who can approve changes. There are many different ways of setting that up. Sometimes you can, for example, add the option that only people that actually touch that code already or are responsible for a specific file can actually review that. But usually the person owning the code base can review it, and every collaborator he adds to the repository.
And is it possible to change a repository that has previously been set to public to private?
Oh, I can't answer that actually. I don't know if that's possible. Maybe it is. I wouldn't know. You have to check the settings, of course. If you have a repository, you can check the settings. I actually think you can set it to private, but maybe I'm mistaken.
All right. That's all the questions I see in the chat. Does anyone else have any additional questions for Karsten today?
There's another question, I think.
What roles are available on Git, and can we create or modify?
I know there's an admin role. I know there's a and I think there's another collaborator role or something like that. And of course, you can modify those. Yes.
And here we have to be precise, right? So Git itself, I think, does not have any
Sorry.
roles.
Oh, yeah,
GitHub
yes.
or similar solutions have. So you have to really understand that GitHub is a software that uses Git or a service that uses Git, but Git itself is separate from that, right?
Yes.
So there's, for example, also Git Kraken and other versions that are similar to GitHub.
Please, can you tell us about some common merge conflict situations and how to avoid them?
Okay, that's an interesting question. I would rather, I know as a beginner, you feel like you're supposed to avoid merge conflicts as much as possible because they're very tedious and difficult to solve. I think if you have the right tool, then you will learn at some point to actually appreciate them. So avoiding them, basically, I would say, means that you are more aware of which files and which code you are changing. So if you really want to avoid them, that means that like if you have two branches, in this case main, and you have your own feature branch, and you are developing a feature in one line of in one file, and at the same time another person is changing exactly the same file on main, you'll have a merge conflict. So if you want to circumvent that, then of course the only thing I can say is don't change the same file. But then again, that's a bit against what Git is supposed to support, right? Which is basically actually solving those merge conflicts. And that's the second part. I think instead of, it's not an error, it's actually a feature. A merge conflict is an amazing feature in Git, actually. I think the second part would be use the tools that we mentioned earlier, like either the command line or one of the GitHub tools or the other apps to actually visualize. Maybe even VS Code, I think, has a feature like that as well. And I think PyCharm, for example, does too. Use those tools to visualize those merge conflicts and solve them, and do that a lot. And at some point, you will definitely get used to it, and it will just be part of your normal workflow. And lastly, check git log one line graph to see what's going on. That usually is very informative as well. I hope that helps.
Yeah, thank you. There was also a question about what we should do now for the ABW cases. So for the fellowship project, you'll be receiving information next week explaining what the project entails. So for right now, I would just recommend that you start to get familiar with Git by using it. Are there any additional questions from anyone? I don't see any. Then I think
Great.
we can finish the session here. Karsten, you'll be uploading the slides to
Yes.
the GitHub.
I'll try.
We'll also share the recording. Oh, and before I forget, please everyone go ahead and take 2 minutes to fill in the survey for this training. I've just dropped the link in the chat. Please, your feedback is important, so please take a couple seconds. All right. Thank you so much, Karsten.
Thank you. I hope that was helpful. And have
Have a
fun
good
with
day.
Git. Thank you. Bye.